Okay, so let's get started on our questions here. So the first one was correct. So I'm going to put a check mark. And okay, question 2 is partially correct. So let's go ahead and talk about what's going on in this one. So we're given that measure of angle A is 65 degrees and measure of angle F is 65 degrees. So that means that these two are congruent, these two angles. We're also given that segment AE is congruent to segment FR. And we're given that angle T is congruent to angle P. Okay, so let's go ahead and talk about this here real quick. So which shortcut can be used to prove that the two triangles are congruent? There may be more than one answer. Select all that apply. So the one that you selected, side angle side, is incorrect. This one's wrong. Why is that one wrong? Remember that side angle side means that we need to have two pairs of congruent sides, corresponding congruent sides. But we're only given one, right? Which is AE and FR. We know nothing about this side and this side, whether they're congruent or not. We also know nothing about the side down here and the side over here. So we can't use side angle side. We would need to know something about one more pair of corresponding sides. You'd have to know that that pair is congruent. Those two sides are congruent. So we definitely cannot use that one. And then you wrote angle, side angle. Now, this one, I'm going to write that this one's okay. So there's a reason why. And I notice that in the question, they don't mention intermediate steps. So let's talk about why I would say that angle, side angle is correct. If this angle is congruent to this angle, and this angle is congruent to this angle, then we know that the third angles must be congruent as well in a triangle. So that means that E is congruent to R. So we immediately know that. Now, knowing that, we can see here that you have an angle congruent to this angle. You have a side that's in between two congruent angles. So this side is congruent to this side, and this angle is congruent to this angle. So we can use angle, side angle, because this angle and this angle are the same, this side and this side are the same, this angle and this angle are the same. So this is the reason why I would say that this is fine. But don't be surprised if they were to mark it wrong. Suppose that you submit it and it's wrong. I can already predict what the thing that they would say is would need more argumentation. So why would they say need more argumentation? Because notice we didn't, from the given information, we didn't know that these two angles were congruent. We had to bring in extra information that we already knew, which is that when you have two angles or two pairs of angles that are congruent, then the third pair has to be congruent in a triangle. So using that theorem, we were able to get to angle, side angle. But notice that's an intermediate step. So if you want, you can send an email, or you can risk it, and if it's wrong, then we can send him an email and that he should fix it. Because this is not entirely clear. I'm going to put here, are we allowed to use intermediate steps? Question mark. Or is it strictly from what's given? And the reason why this is a subtle point, but the reason why I'm talking about it is because in one of the questions later on, they actually do specifically say no intermediate steps. They say that. So if they say that there, but they don't say it here, then I'm assuming it's okay to have intermediate steps. If they said that you can't have intermediate steps there, and they don't say it here, but they mean that you can't have them here, then that's inconsistent. That's a problem, right? Because that's ridiculous, right? There's no consistency, right? Either they say for all of them or they say for none of them, right? So that's important. So let's see. All right, so we're allowed to use intermediate steps question mark. All right, and then there's definitely one more, and I'm not going to give you the answer, but it's obviously either going to be this one or this one. There's one more that we definitely need to include. But remember, I'm not supposed to be giving you the answer. So, must include one more. So that's my hint. So it's either this one or this one. And definitely we know from the information in the given, over here in the given statements, right? Okay. So that takes care of question 3. I'm sorry, question 2. In question 3, the same thing happened. Question 3 it was partially correct. Let's discuss why. So what do we have in question 3? Let's see. Which of the following is a shortcut for proving triangles are congruent? There may be more than one answer, so select all that apply. Alright. So first of all, yes, side, side, side is correct. That's one of our statements. Another one is angle, side, angle. That's also correct, so good job on those. Also, good job on angle, angle, angle. This is definitely not correct. You can have triangles that have congruent angles, but are not congruent. They're different sizes. These can be similar. I'm just going to write that. So you can have a case where you have similar triangles in which they have congruent angles, corresponding congruent angles, but are different sizes. So they're not congruent. So definitely that's not one of them. I want to talk about this because I noticed you made this mistake many times in this assignment. There's no such thing as side-side angle. So side-side angle does not exist. It's not. If you go to your theorem list or in the modules, if you look at the different ways of proving that two triangles are congruent, side, side, side is not one of them. I don't want to get into the details. I should, though, because I want to make sure you understand. But this is not something you have to know for the course. I'm going to explain this just so that you know why this is not correct. If you had two sides that are congruent, I can actually construct a triangle. Watch. So I'm going to do this. So I'm going to say that you have an angle here, and then you have a side here. Okay. And I'm going to use blue, so I'm going to change the color to connect the following line here. And then I'm going to use a different color because I want you to really understand what's going on here. I'm going to use this purple over here to connect this over here, because you can also do that. Okay. So what am I doing here? Why am I writing this? Because you can actually draw two different triangles that have this other pair of congruent angles in, like, let's say, different spots. The first one looks like this obtuse triangle right here. Gonna draw it like that. So this has, you can say you have the side angle congruent to, and then I'm gonna draw another triangle way over here, like that. Say. You see, this side is congruent to this side. This side right here is congruent to the side over here, and the included angle, not the included angle, the angle on the left side over here is congruent to the angle on the left side over here. So both of these triangles fit this category of side-side angle, but they're not congruent. Now you might be wondering, how do we know they're not congruent? When I constructed this picture, you see this purple line right here? This purple line means that you're adding more length right here, basically, is in this picture. So the purple line is just a little segment, a little part right here where it extends outwards, right? So that means immediately this third side is not congruent to the third side over here, right? And we know that if two triangles are congruent, then all of their corresponding parts must be congruent. So definitely side angle is not one of our congruence theorems. So no, it's not there. I'm explaining this I'm explaining this because you kind of use this idea a couple of times in the assignment. So there's some misconceptions here about that. All right, so that's important to make sure that we get. All right, so that was question 3, and let's see, question 4. Is this one correct? No, this one was not correct. All right, let's talk about why question 4 is wrong. Question 4. Why was this one wrong? Okay. So, what you're stating here is that triangle TOP is congruent to ZAP using side angle side. So I'm going to critique the proof here, or the argument. First, let me just draw this so it's a little clear. This is the given information. Notice, in our given information, do we know anything about the third sides? About another pair of sides? We know nothing about this pair of sides. We don't know if they're congruent or not. And likewise, we know nothing about this pair of sides. So there's no way that we could use side angle side, because we would need to know more information. We need more information about one more pair of sides. Now I'm not going to give you, so we know that that's not correct, right? So it's one of the other 3. I'm not going to give you the answer, but I'll give you a hint. And you've used this before, so you definitely know this. These 2 angles are also congruent. Why is that? Because we have something called the vertical angles theorem. Vertical angles theorem. So we know that the angle, OPT, is congruent to angle. We did OPT, so we're going to do OPT, so we'll do APZ. Angle A. I'm going to go in the same order, so let's do APZ. Okay. Alright. So we definitely know that, so I'll let you use that information to figure out what the answer is. That was for number 4. Let's go to question 5. Okay. Question 5 was wrong. What was this one? Okay, let's look at question 5. Segment CD is congruent to segment EA, and AD, segment AD, is a perpendicular bisector of CE. Using only the given information, not any additional steps or calculations. Which shortcuts can be used to prove that triangle ABE is congruent to DBC? There may be more than one answer, so select all that apply. So just directly from the given information, we know that CD, this guy, is congruent to EA, which is over there. And if AD is the perpendicular bisector, so AD is this line, if it's the perpendicular bisector of CE, then that tells us that CB is congruent to BE, and we get 2 pieces of information. And this is a 90-degree angle, and this is a 90-degree angle. So we immediately know that. Okay? We don't know anything else, just that. So let's go ahead and go through our different choices here. Side angle. Well, is that a theorem? Is that one of our statements? We discussed that in the previous question over here. Side angle does not exist. It's not one of our congruent statements, so no, it can't be that one, because there is no such thing as side angle. We discussed that, where it's possible to have two triangles that have the same sides that are consecutive with an angle not included between them, congruent. Angles not included between congruent, but the triangles not being congruent themselves. We already talked about that. So side angle, definitely not there. So no, not that one. You wrote angle side. Well, do we know anything about the other angles? So from the given information, do we know absolutely anything about an angle up here, or the angle over here, and the angle down here, or the angle over here? It seems like all we know straight from the given is that this is 90 degrees and this is 90 degrees. That's all we know. So for angle side, you need two pairs. Of angles. Let's put that. Corresponding. I'll put the word congruent first. Congruent corresponding angles. So we would need two pairs. We only have one pair, which is the 90 degrees, so we can't use that one either. So no, it's not that one. So I'm not giving you the answer, but I'll let you pick. And it's not this one. This will just be, I'm just eliminating this one right off the bat. It's definitely not that. So I'll let you decide from the remaining ones. Is it both of them or just one of the two? Okay, that's question 5. Let's look at question 6. Was that one correct? Yeah, question 6 is correct. Good job on that. So we're not gonna go through that one. And question 7 was wrong. Okay. Yeah. So I sent you a text message. And obviously, I mean, if it's wrong, then you know it's the other one, right? But let's talk about why, though. I sent you a picture, and it's in your text messages, of the triangle inequality theorem, which states that any two, or the sum, I should say, of any two angles is greater than the third. Now I want you to be very careful with this. There are actually two versions of the triangle inequality theorem. In high school geometry and in our course, it's saying that any two sides, I wrote the wrong, I'm sorry, I'm in angle mode right now, so I'm still thinking about angles, but we're dealing with side lengths. So the sum of any two sides is greater than the third side. Sorry about that. Okay, so where was I? There are two versions. So one of them says that the sum of the two sides is strictly greater than the third one. So A plus B has to be bigger than C. That's the one that we're using. But if you look online, if you were just to search triangle inequality theorem, you might find one that says A plus B is greater than or equal to C. Why would that be the case? Why is that okay? Well, this is because this version allows for something called a degenerate triangle. And in geometry, some of the definitions allow for kind of, what's the word I'm looking for, like deviant shapes. A degenerate triangle is just a line. I know that's ridiculous because you're looking at that like that's definitely not a triangle. Well, that's why they qualify that with the word degenerate. You'll see this also in pre-calculus in the context of conic sections. I'll talk about degenerate conics. But this is kind of irrelevant and beside the point. I'm just bringing this up because if you Google this, you might find this version of the triangle inequality theorem. So I want to make sure that we don't get confused with these two, because I don't want you to say, hey, look, I Googled it, and on a university website, it had, greater than or equal to C. And then there's a discrepancy, right? Is it just greater than or greater than or equal to C? Well, it depends, right? In our class, we're using this because we're specifically excluding degenerate triangles. Okay, so let's talk about why your answer is wrong. Your answer is wrong because 4 plus 8 equals 12. So the statement 4 plus 8 is greater than 12 is not true, right? Because when you add 4 and 8, you get 12, and obviously 12 is not bigger than 12. And remember, a triangle inequality says that the sum of any two sides must be greater than the third side. So here we can see that we added two sides, and their sum is not greater than the third side. Okay? So this is not, that one's wrong. So it's not this here. It's not true. Okay? Question 8 is correct. So took care of that one. Let's look at question 9. Alright. So I'm not saying in question 9, this is kind of a bad question because it's really two things. There's another like sneaky, little subtlety here. So if this ends up being wrong, then we can send an email to the teacher because it's a little unclear. It says, to prove that triangle ADC is congruent to CBA, what additional information needs to be proven? Okay, so the first thing I'm going to do is redraw this to have two triangles that are next to each other. And they would end up looking like this, DCA, and I'm going to put the little 1 there. And then we would have, and this is a 90-degree angle, this is a 90-degree angle, and we have B, A, and C with a 2 right there. Okay, that's what our two triangles look like, two right triangles. Now, what you said is perfectly reasonable. This is I would, if I were grading this, first of all, I wouldn't write a question like this. It's kind of a bad question, but I would allow for this to be a correct answer, and there's a reason why. When you're writing a proof, you need to make sure that you use the reflexive property when it's needed. In this case, we need to know that CA is congruent to CA. Of course, to use the reflexive property, it would have to be written exactly the same way. So it would have to look like this. Segment CA is not congruent. Segment CA is congruent to segment CA. This says AC is congruent to CA. So technically, this is not the reflexive property. Even though, if you were to analyze this philosophically, these two symbols, right? You're looking at the symbol right here, that symbol, and you're looking at the symbol over here, refer to the same thing. So this symbol and this symbol refer to the same thing, namely the diagonal, right, of this rectangle. So two different symbols, because the symbols are not the same, right? One has AC, one has CA. It's two different symbols that have the same referent. So if you want to be like the philosopher Gottlob Frege, you can argue that case, right? That these are just two different symbols that refer to the same thing. Just like perhaps your first name and your middle name both refer to you, even though the two names are different, right, in most cases. But in math, when we write the reflexive property, whatever is on the left side, so blah on the left side, needs to be exactly the same as blah on the right side. So you have something, relation, something, the two somethings need to look exactly the same in order for us to apply it. Okay? So even though this is technically okay, I mean, it's not written correctly. Of course, at the UT high school, they might not even care, right? Which is kind of sad because it's not correct. This is not one that I would. I mean, I would accept it, but that wouldn't be the best choice. Let's talk about another one. And this is the one that I do want you to select for the answer. So, it's clear, right? It's evident from the drawing, right? From the diagram, even though we don't like to use diagrams, but it's evident from here that they share the same side AC, meaning that they're equivalent. We know that. But notice that here it's saying to prove triangle ADC is congruent to triangle CBA by hypotenuse leg, what additional information needs to be proven? Well, if we need to show hypotenuse leg, we need to know something about the legs. So we need to know that either DA is congruent to BC over here, or AB is congruent to CD. One of those two statements. We need to know that. Now, you might be wondering, well, we already know that just from the picture because it's a rectangle. My objection to that would be no, because we haven't gone over the chapter with quadrilaterals, which is where you study rectangles. So at this point, we really know nothing about rectangles. We don't know that opposite sides of a parallelogram are congruent. We're technically we're not supposed to know that because we're building the geometry from the ground. We're starting from the foundations and we're working our way up. We can't teleport, time travel into the future, learn about rectangles, and then come back to this moment and say, ha, so we know that they're the same. We technically can't do that yet. So we would need to know, and that would be this one right here. We would need to know that one of the other pair of legs is congruent. So you would have either like AB and CD or DA and BC. In this case, it's this is the one that's in the choices, so I'm gonna go with that one then. All right. Okay, and then now we're on question 10. Oh, this is a fun one. I printed out your argument because it's interesting. Where is it? Oh, here it is. Okay. So I'm going to draw real quick the picture here. It's a bow tie. I have a bow tie problem. It says this is T, this is U, and this is R. This guy is congruent to this guy. This one's congruent to this one. This is S, and this is Q. Okay. And we want to prove what? We want to prove that angle Q is congruent to angle U. Okay. How do we do that? Well, like I said, I'm not going to give you the right answer, but I'm going to, first of all, critique your argument and then give you some pointers. And then you can fix it, and then I can recheck it to see if you got it this time. So let's start here. Your first line is correct. The given statement. Good job. Check mark. So that's true. Good. Next one is it's correct, but you need to fix it a little bit. So we need to fix this. First of all, the reason would be vertical angles theorem. You have to include that. It's not just vertical angles, it's the vertical angles theorem. By definition, if you just get the definition of vertical angles, the definition doesn't say they're congruent. It's a theorem that needs to be demonstrated in which they're congruent. It's the theorem that tells us that. That's the justification that we use. So vertical angles theorem. Okay. And one more subtle point is this, the way you named it. So make sure that when you're naming things, you're writing them in the correct order. So if this is QRS, we have to go in the same order. So think about it like this. Here we have QRS, right? That means that on this side, if we want to, and that's, by the way, that's correct, right? That those are vertical angles. So I'm going to write it right here. It's congruent to this one. If we're doing QRS, then we need to start with a U over here and then move to the R, because this line segment is congruent to this line segment. So you have to do URT. Okay? If you want to redraw the triangles, feel free to do so. This is not, you don't have to put this as the answer. It's not part of the answer. But you can draw it on the side just so that it's clear and it makes sense. So you can write it like this. So this is Q and then this is S. That means that this here is congruent to this, and then this one's congruent to that. So this would be U, and then on the other side would be T. So the side RT is congruent. RT is congruent or corresponds to the side RS right over here. Yeah, so you can rewrite it just so you can get the order. If that's confusing. Yeah, so that's just a pointer there. So really this one should be angle Q. What did I write? Let me do that one again. QRS is congruent to angle URT. So that's angle URT. Okay. All right. The third line, incorrect. The whole thing's incorrect. Why is that whole thing incorrect? Alternate interior angles are only used when we have parallel lines with a transversal. Parallel lines with transversal. Nowhere in the given statements do we have any of that. There's no way we can use that here. So we don't know that, QS is parallel to TU. We don't know that. It might look like it, but we can't use that because it's not in the given statements, and we can't arrive at it from the given statements using anything we've done above this mark, right above this point. So you can't use that. So no parallel lines in this. And I'll give you a hint. You never use parallel lines in this whole proof. So no parallel lines with transversal. So don't bother with that. So you're not using that here. Okay. Line 4, that's also incorrect. Why in the world is line 4 incorrect? There is no such thing as side-side angle. Again, I think this is the third time this came out. Okay, side-side angle, no such thing. So, nope. So it's not that. And then again, line 5 is also wrong. Why is line 5 wrong? Because again, alternate interior angles, same thing here. In order to do that, you need to have parallel lines with a transversal. We don't have any of that information here. So the whole line is wrong. So we have to just delete those last three lines. You just delete them. Okay. So let me give you some pointers here. What can we do? I'll give you a hint. First, you need to prove that the two triangles are congruent. This triangle and this triangle. And I'll give you a hint. There's already enough information on here to prove that the two are congruent. There's already enough info. We have a side here, an angle here, a side here, and a side here. Which one of our statements do we use? I'll let you think about that. But remember that once you prove that two triangles are congruent, then you can use CPCTC, which stands for corresponding parts of congruent triangles are congruent. Okay? So that means that all of the corresponding parts, like angle S would be congruent to angle T. And we would just need to look at what we're trying to prove, right? We're trying to prove Q is congruent to U, right? So there's Q, here's U. So we'll have to use that information then. So at some point you're going to be using CPCTC. Okay, so I'll let you go ahead and finish that up, and that concludes this video.